Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem subset sums. So we can see the problem statement is given an array ARR of integers. We have to return the sums of all the subsets in the list, and we don't need to care about the order. So for in the example one we can see that input array is given. I'm taking the same example one here. The array is given 2 comma 3, and we need to return a vector or an array which will be storing the sums of all the possible subsets. So we know that for any array of size n, here the size is 2, all the possible subsets, how many possible subsets will be there? We all know, according to maths we studied, we all know 2 to the power n subsets are possible. So in this case 2 to the power 2, that is 4 subsets are possible. So we just have to return, we don't need to return the subsets, we need to return the sum of all the subsets storing in a vector. So how we can do this? So the brute force approach which can come into my mind is I can go and first of all calculate all the possible subsets. This will take 2 to the power n time complexity, and then iterating, first I will store all the subsets in an array like a power set. Now I will go in each and every subset, and I will just sum them, and then I will again create a resultant vector which will be storing the sums. So this will take big O of 2 to the power n into n time complexity. All right, now how can I optimize it? So we can optimize it through recursion. How recursion? We can just pass a sum variable there, and then we can directly, in the base case, we can add that sum into our resultant vector. So how I'm going to explain you. So I'm going to solve this. So my array is 2 comma 3. I'm taking the short example, the example 1. Now what I will do, I have if I have to form a subset, I will check that if I need to take 2 or not. First of all, let's say my I is here, so I will say my I is 0 in this case. In this step, in this level I is 0. So option is either I will take 2 or I will not take 2. So if I take 2, so my new, let's say my a subset will become 2, and if I do not take 2, this will be empty again. Now moving ahead, when I is equals to 1, I will move. Now I have option that I will take that 3 or not. If I take 3 or not, similarly here, if I take the ith index or not, or if I don't take. So if I take, so this will be 2 comma 3, and if I do not take, this will remain 2. If I take 3, so this will be 3. If I do not take, this will be empty. Now again moving ahead, I is equals to 2. Here I will move. Now it is out of bound. Now at the end it will not go here. Now we can see in the last level, we can see our all subsets are generated. Here what I said, 4 subsets will be there, 4 subsets are there. So in the base case, when I will be greater than or equal to size, that is 2, so we can say we can store these subsets, but here we don't need to store the subsets, we need to store the sums. So what I can do, while performing recursion, I can use a sum variable also, which instead of uh, instead of creating subsets, I will store sum. So here my initial sum will be 0. All right, initial sum will be 0, and in this case my sum will be what? Sum will be 2 here, and here sum will be 0. In the next step, here if I am adding 3, sum will become 5. If I am not adding anything, sum will remain 2. Here if I am adding 3 from 0, it will be 3. If I am not adding, this will be 0. So now in the base case I can create a resultant vector global, or I will pass with reference, so I can store there. So these all will be stored. So the resultant array is 5230, and here we can see 5230 all are there, and we don't need to take care of the order. So this we this way we can solve this problem. So I'm going to implement this. So first of all, what I said, I will just store the size of the array, and now what I said, I will perform recursion. So before performing recursion, I need to store the resultant which I have to return. Let's say result. Alright, now I will declare a solve recursion function. There my I will be in the starting what? 0, and my sum in the starting will be 0, and I will just pass array, the size of the array, and yes, the resultant vector. Now at the end I will just return the resultant vector. Now I just need to write the recursive function. This will be returning nothing, but yes, it will be performing recursion. So here first of all the index, then the sum, then this array, then size, then again resultant array. Now what is said in the base case? Base case was when I was greater than equal to size, that is greater than equal to n, I will just store my sum in the resultant array, and from there I don't need to move ahead, I will return. And now in normal recursion, what I will do, I will either take the ith value or I will not take. So either I will take or not take. So if I take, so what I need to do, I want to go ahead. So here first of all I will go ahead I plus 1, and sum, if I take, sum will be what? Sum will be increased with the current value of I. So current value of I will be ARR of I. Now ARR vector I have to pass, size I have to pass, resultant vector I have to pass, and if I don't take, so I have to move ahead, and sum will remain sum, and these are all the parameters. Now this way, if I submit this, now we can see that if we haven't done any mistake. So yes, we have solved this problem successfully now. And if I tell you the time and space complexity, so we can see we are performing recursions, and each value, at each value we have two options, either we take or we don't take. Here also either we take or we not take. So total n values and two choices. So 2 to the power n subsets are there. So the recursion is also calling for generating all the subsets. So time complexity will be big O of 2n. All right. So if I write here, so time complexity will be big O of 2 to the power n, and space complexity we can see that we are storing the resultant vectors. So resultant integers. All right, so this is a resultant vector, and here we are storing all the sums as integer, and those size will be what, all the subsets. So this will be, the size of this will be big of 2 to the power n, because we are storing all the possible subset sums. So this is all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.